In this example, we're told that a simple random sample of size n is drawn from a population that is normally distributed. Because we're told that statement, we don't need to check any conditions for normality. We're also told that the sample mean is found to be 106 and the sample standard deviation is found to be 10. And then we're asked to construct several confidence intervals about mu, the mean of the population, given different sample sizes. To construct these, we're going to use StatCrunch. So over here in StatCrunch, I will go to Stat, T-Stats, one sample, and notice that I have some different choices. If I were given the list of data from that sample, I would select with data, but in this case, I'm going to select with summary because I'm given the sample mean and standard deviation. So I'm going to select that one and input that information here, that the sample mean was 106, the standard deviation from the sample was 10. This first sample size for part A, n, is 28. And then I need to give StatCrunch the confidence interval, which in part A is 80, or 80% or 0.8. And notice you have some other options that you could select as well, but this is enough for what we need, and I'm going to select compute, which I know is a little bit off my screen, but I'm trying to show this as large as I can. So this gives me my lower and upper limit for the confidence interval that I was asked to construct in part A, rounded to 1 decimal place. In part B, I'm asked to basically do this again. So instead of going back to the very beginning, which is still an option, you could come up here to options and select edit. So in this case, it's like you're editing the calculator that you just built. And notice that the only thing that's different in part B is the sample size is 20. Everything else stays the same. I'll compute, and now I have a new lower and upper limit. And there's a follow-up question to this. How does decreasing the sample size affect the margin of error? And I can compare this interval that was constructed in part A to the one constructed in part B, where the sample size decreased, and see that the margin of error must have increased because this interval is larger. In part C, you're asked to do this again with some new information. So let's go back to StatCrunch and edit our calculator here. So I've updated my calculator. I'll click compute and I get a new lower and upper limit. We are also asked a follow-up question here to go back and compare this interval that we just obtained with what we had in part A. So keep this in mind. In part A, we constructed an 80% confidence interval with a sample size of 28. In part C, we constructed a 70% confidence interval, also with a sample size of 28. So by decreasing the confidence interval, we also decreased the interval itself. Notice that the lower and upper bounds are closer together here. The margin of error decreased. We could think of it like that. Or as stated here in the choices, as the level of confidence decreases, the size of the interval decreases. And then last in part D is this statement about being normally distributed, and we do need to have a population that is normally distributed in order to compute these confidence intervals that we just constructed.